Hello everyone, this is Mix K. Today I'm going to be going over isotopes and the atomic numbers of isotopes. So isotopes are atoms of the same element that have different masses. So what makes the masses different? It's going to be the number of neutrons. So what's nice about this is that the neutrons have no charge. So when we change the number of neutrons, the charge is going to stay the same. And when we change the neutrons, every time we add or take away a neutron, our mass is just going to go up or down by 1. Now, the reason we do not change the number of protons is the same reason we don't change the protons in ions, and that's because our protons tell us what element we have. So if we change the number of protons, we're completely changing the element. Now, this can happen in some radioactive reactions, nuclear reactions. But for today, we're just learning how to find the atomic number of these isotopes. So when we look at isotopes, we have a few different ways to write them out because they have different masses. Now, we usually can just look up the mass on the periodic table, but that mass is closest to the most common mass of that element. Now, for us, we're going to need to get the mass from me or from the nomenclature, the name or the symbol, because the mass is not going to be the same, as the periodic table's mass. This is where we get that average mass from. We have all these different masses for the same element and average them together to get that number on the periodic table. So moral of the story is I have to give you the mass in some way or form. So here are 2 ways I might give you the mass besides just telling you it. We have the nuclear symbol. Now the nuclear symbol is written with the symbol of the element, and then we put the mass number on top and the atomic number on the bottom. So it's almost like we switched what our periodic table looks like. The reason we put the mass on the top is because the mass is the most important number for the atomic number. The other way we can do it is the hyphen notation. In hyphen notation, we either use the symbol or the full name of the element, then we put a little hyphen, a little dash, and then the mass. Okay, so you can either find the mass in the hyphen notation at the end or in the nuclear symbol at the top. Okay? So the only 2 things that are going to change when we look at an isotope of the same element is the mass and the number of neutrons. So let's start with these 3 examples of carbon. Okay, so if we look at these 3 examples, we have C12, C13, and C14. So first off, let's go look at the periodic table. Now we cannot use the mass of this carbon on the periodic table. This is the average, but we can get the atomic number. So our atomic number of carbon is going to be 6. And this is going to be the same for each carbon isotope because the isotope or the element we have here is carbon. And the atomic number will always be 6 for carbon. Now, the atomic number is always going to tell us our number of protons. So this is also going to be 6. Now, when we talk about isotopes, we're talking about neutral atoms. So unlike ions, the electrons are also going to be the same. So right now we have atomic number, protons, and electrons are all the same. Now let's look at what's going to be different for these 3 carbons. So if we look at the atomic numbers here, or not the atomic numbers, the nuclear symbols, we can see that there's a little number at the end for each. This number is our mass. It's telling you the mass right here. So for this one, it's 12, this one is 13, and this one is 14. So if we come over here to find our number of neutrons, we're going to do the same thing, but we're starting with a different mass each time. So for C12, we do 12 minus 6 is 6. For C13, we do 13 minus 6 is 7. And for C14, we do 14 minus 6 is 8. So when we look at these, the number of neutrons went up by 1, and the mass went up by 1. So those were the only things that make these elements, or these atoms, different from one another. They're all carbon, but they have a slightly different mass. So let's try these hydrogen ones. Now for this one, we can see the two numbers here. The bottom number is the atomic number. So we know the atomic number is 1. The protons will be 1, and the electrons will be 1. Now to find our mass, we want to look at the top number. So for this one, the mass is going to be 1, and for this one, the mass is going to be 2. So to get my neutrons, I'm going to do mass minus protons equals 0 for each one, and then mass minus protons equals 1 for each 2. Okay? So when we're doing this, the protons and the electrons will still equal the atomic number. I'm going to have to give you the mass from somewhere, and from that mass, you can find the number of neutrons. Mass minus protons equals neutrons. Let's just do a little bit of mixed examples. So here we have just a bunch of different examples of carbon, okay? And you'll have to do a little bit of mixed examples for homework. So let's look at carbon on the periodic table. So we can see that for the regular old atom of carbon, we have the atomic number is 6, and the mass is 12.01. So let's go put that in for the first row. So our atomic number is 6, and our mass is 12.01. So we're going to round that down to 12. Now the protons are going to equal the atomic number no matter what. And here we have the neutral atom, so the electrons are also going to be equal. To get our number of neutrons, we're going to do mass minus protons equals neutrons. Mass minus protons equals 6 neutrons. Now we're going to skip the ions for a minute. Let's do the isotope next. So in the isotope, it's still a neutral atom. It's still carbon, so the atomic number is going to be 6. The protons are going to be 6. And the electrons are going to be 6. Okay, they're all neutral atoms for isotopes. Okay. Now for our mass, we can't just get it from the periodic table. We have to get it from the symbol over here. So it's a C14. I'm going to put 14 right there for my mass. Okay, to get my number of neutrons, I'm going to do mass minus protons equals 8 neutrons. Okay, let's go back to our ions. Okay, so here we have our 2 ions are both carbon. So if they're carbon, their atomic number's got to be 6, and their number of protons has to be 6. Ions have the same mass as the neutral atom, so they're both going to have a mass of 12. And when we do our subtraction, mass minus protons equals neutrons, they're both going to have 6 neutrons. Now what makes them different, though, is going to be our number of electrons. So in the neutral atom, carbon has 6 electrons. Here we have a positive 4 charge. So if it's positive, that means it lost negative electrons. So we're going to subtract 4 and get 2 electrons left. Here it's negative 4, though, so the opposite happened. We gained negative electrons. So we're going to add 4 here, and we get 10. When your ion is positive, you subtract from your electrons. You do the opposite of the charge. When it's negative, you add to the electrons. You do the opposite of that charge. Okay, so that is it. I hope this video helped you out, and have a lovely day.